Okay, so we're on page 182. All right. So number 10 and 11, we put those extra values in there. And we have their number 10, f of x equals 4x minus 2. And 11, f of x equals 4 times 1/2. And then we have this x plus 1 up here. So what we need to do is we need to look at this other way to write this. Yesterday we talked about y equals ab to the x. Today we're going to add to that. We have the ab to the x minus h, all plus what? K. So we're going to get the hk shifts today. Okay? H, remind your neighbor how h shifts the graph.
Up and down.
H is coupled with what letter? H is coupled with what letter?
Y.
Which one's it with up there?
X.
It's with x. Okay? That means it's shifting on the x-axis. Shifting right, left. K is shifting up, down. Okay? So remind yourself here. K shifts up, down. Okay? If K is positive, it shifts up. If K is negative, it shifts down. Okay? Okay, get it? All right. And this one is H. Where's Abby?
Went to go get a paper from
That's ridiculous, man. Remember your books. Unbelievable. Nice job, man. If I was Vogel, I'd say no. You notice I don't make the copies. Okay?
You used to.
I'm not anymore. Okay, not for the books. Vogel does that. I know, I'm too mean. Okay, H shifts left, right. It shifts left when H is what? Positive. It's kind of backwards. It shifts left when H is positive. So it goes that direction when H is positive. Okay? Shifts right when H is negative. Remember we talked about it being whatever makes this 0 in here. Okay? She probably has this page from yesterday. It's probably on the, did she get rid of it? Did she sell that on eBay?
Probably.
Jiminy Christmas.
So you can sell your notes. Yeah, you can.
All right.
No, she doesn't have it, so.
Hey, that's today's worksheet. Where's your packet from yesterday?
It's right there, but it doesn't have it on it.
Did you turn to the back page?
Yeah.
Oh.
It's not on there.
Oh, well, bummer, man.
Is this not today's work that you're looking at?
No, that's our assignment today. You're missing out on all this stuff.
It stops at 9.
Bummer. That's too bad. I don't know what to tell you.
No, I don't.
Oh, I do know what to tell you. Bring your workbook. Hey, does anyone have a workbook out there? Raise your hand if you got a workbook. Oh.
What are you saying? Are you asking?
You may have to follow along with a friend. All right.
Why did you say
Unbelievable. Huh? All right. So what I want to do is I want to graph this. Let's make a table of values. Okay, we're going to go X. We're going to go Y. Tell your neighbor what we're putting in the middle there. Yes, you're correct. It is 4 to the X minus 2. Okay, that's what we're putting in the middle there. What's the finding?
-2 or 0?
We're going to find 0. Why are we finding 0 for X?
So we know what it equals.
Good. That's the y-intercept. So 4 to the 0 minus 2. 4 to the 0 is? 1 minus 2 is? 1 minus 2 is -1. Good. That means my y-intercept is at?
-1.
-1, which seems kind of weird, right? Because in the past we said what value is our y-intercept? Remember yesterday, what did we say in here was our y-intercept? What letter? A. Well, what's A in this? No, it's a thing not attached to the power. It's 1. Yeah, so Josh is saying since there's this -2, we went from our y-intercept being here to now our y-intercept being 2 lower. Dude, 2 down. Nice. All right. In fact, we could have said, well, what's 4 to the first? 4.
First 4.
Okay, so rather than having, excuse me, this should be a 1. Rather than having 1 and 4, you're going to actually have to subtract 2, and it's going to be 2. 2. as I like to say, 2. Okay?
Wait, why would you go out? Oh, because yeah.
All right? You think we got it?
I think so.
All right. Go ahead and finish up the table there. Good point here. When we put the 2 in, we get 4 squared, and 4 squared minus 2 is 16 minus 2, or 14. And the way we've made our scale here, 1, 2, 3, 4, 5, 6, 7, that's not going to fit. So we probably should have went up by 2s. I can't do that because I'm doing it in pen, but many of you, you're doing it in pencil like you should, and many of you haven't even started your graph, so it's okay. You can go up by 2s there. Okay. If you started going up by 1s, that's okay. What we could do, 4 to the negative 4th is, or first is 1/4 minus 2. A fourth, or if you're at negative 2 and you put on a 4th, right? You're at negative 2 and you add a 4th. What are we at?
Wait, why would you?
All right, let's say you're at 1/4 and you subtract 2.
You're at negative
1 3/4. Negative 1 3/4. Okay, so at negative 1, I'm at negative 1 3/4, which is right there. And then at negative 2, that's 4 to the negative 2nd, which is 1/16, or 1 over 4 squared. Minus 2 is negative 1 and 15. No, hold on. Yeah, 15/16. Which brings me really, really close to this line. Will I ever hit this line? No. Okay? I'm getting infinitely close to that line. So since my graph, since I couldn't put the 14 on there, I'm just going to stop before I cross the 2 line. I know 2 is going to be way up here somewhere at 14. It's like way, way up there. Okay, on mine.
What is 4 to the negative 2nd?
4 to the negative 2nd is 1/16. 1 over 4 squared.
Okay.
Right, I'm just assuming you guys know how to do that now. 4 to the negative 2nd is 1/16. I assume you just do 4 to the negative 2nd is 1 over 4 squared, and that's 1/16. If you can't do it, that's okay, but you got to practice it. So that means before you punch it into your calculator, take a guess, try to remind yourself, challenge yourself to get the right answer first. Yeah.
So, if you were to do.
Okay, we'll come back to your question. Your domain. Domain is x. Is this ever going to end on the x-axis?
No.
Will it always keep going this way
Yes.
for the x? Yep. Will it always keep expanding out this direction for the x?
No.
It looks like it's going slowly, but it's still moving outward, right? But it's going really slow. The other way to check is you say, is there anything I can put in? I can't put in. Like, could I put 1,000,000 in for x and get out an answer?
Yeah.
Yeah. I mean, it's going to be a huge answer. When you do 4 times itself 1,000,000 times, that's huge, man. Okay, so when you go out to 1,000,000 this direction, now we can't fit it, obviously. We're going to be going way, way up. All right, so the domain is all real numbers. All real numbers. If it doesn't stop moving on the x-axis, it's all real numbers. Where does it stop moving on the y-axis for a range? Yeah.
-2.
Good, -2. It's approaching -2. So that means y is approaching -2. Now, from the line -2, which, if I were to highlight it on here, from that line, that's the line I'm approaching, am I getting bigger or smaller? Is my graph growing above this line? Is it above or below? It's above. That means this symbol should be
Greater than?
greater than. Can it be equal to?
Yeah. No.
Can't equal -2. It'll get infinitely close. It'll never hit -2. So that's different than the domain and ranges or the range we were doing earlier in the year, where we actually hit the line, right? All right. All right. Number 11. Any questions on that one? Okay, number 11. We're going to do a K shift here, or an H shift, excuse me. Oh, hold on. We better tie this to what we're doing. Man, unbelievable. So as Josh pointed out a minute ago, our normal y-intercept was right here. Okay? 4 to the second, or to the first power is 4. this point used to be up there. In fact, this point right here was actually used to be 2 higher. Okay, the original graph of this kind of looked like that. That's just the 4 to the x. That's what we were graphing yesterday. When we put that minus 2 in, it just pulls this graph down 2 units. That's a k shift. Just drops it down 2. Takes the one that I have here in pencil and brings it down 2 units. Cool? All right. So this one right here, if I ignore the plus 1 right here, if I just kind of cover that up, okay, is that growth or decay?
Decay.
It's decay because it's 1/2, right? It's in between 0 and 1. That means it's going downward. Now that plus 1 is going to take that graph, and what's it going to do? Go ahead and tell your neighbor, how's it going to change it?
It's gonna push it like left or right.
Okay, which way is it going to shift it?
Left.
It's going to shift it left. How many units? 1 unit. So it's going that direction, 1 unit. All right. So if we were to graph this, I mean, there's 2 ways to graph it. You could actually evaluate 4 to the 1/2 and x plus 1. Okay, you could take and actually evaluate that, or you could just say, well, what is 4 times 1/2 to the x? Graph that and then shift it to the left 1 unit. Yeah.
Why can't you just do 2 to the x?
Why can't I do 2 to the x?
Because like 4 times 1/2 is 2.
You're not doing the order operations then, right? You've got to do the power first. Yeah.
Do you have to shift it to the left each time you plug a value in for x then?
Yeah, so yeah, let's try this real quick. If I put 0 in, okay, when I put 0 in for x, if I ignored that 1, okay, that would just give me what number out? What's my y-intercept?
2.
Right, so I hear 4 and 2. So if I ignore the 1, it's 4, right? Is that right?
Yeah.
Okay. If I put the 1 in, it's actually 4 times, let's go ahead and let me write it in here. 1/2 to the 0 plus 1. If I don't ignore the 1, I just put the 0 in there. This is 1/2 to the first power, which is 1/2, times 4, which is 2. Okay? So let's go through and graph it real quick, and maybe that'll answer your question. We got our 1, we got our 2. Is that a 1 plus 1? Excuse me, not 1 plus. Okay. Okay, so that's 1/4 of 4, which is
1.
1. Okay. All right, you guys go ahead and finish up that table there. All right. Ignore my graph for a minute, please, but what did we get for 2 here?
Half.
Half? Everyone agree? Okay. What do we get for -1?
4.
4? What do we get for -2? 8. Okay.
You get 4 for -1.
-1, so 4 times 1/2, -1st, plus 1. So -1 plus 1 is 0. So that part's 0, which,
So you mean 1?
or is 1, thank you, times 4 is 4. Nice job, Decay. All right. I have not graphed these points. Okay? I've graphed the original graph. So this graph that I have in pencil right here is 4 to the 1/2, or 4 times 1/2 to the x power. That's what I've done in pencil. Okay? The points that I'm going to put in pen here, so I've went up by 2's on my y-axis. I'm at 0, 2. I go to 1, 1. I go to 2 and 1/2. Whoops. This point, I messed up on this point. Sorry. Then 1/4 there. Okay, so we got 2 and then 1/2, which now I'm getting so small it's hard to see the difference. But if I go the other way, I got -1. -1 is at 4. And -2 is at 8. Okay, can you guys see the shift of the graph? So here it's shifted this way 1, here it's shifted that way 1, here it's shifted that way 1. Here this point that was right there shifted there 1. It's that's the +1 right there that's shifting it. So what I've done is I've graphed it without the +1 in pencil, and then in pen I've graphed what we just came up with so that we can see the shift there. Okay?
So if for x, can you make x and y different like values on a graph? So
Like going up by different amounts? Yep. Yeah, so here I'm going up by 1s.
Yeah.
And here I'm going up by 2s. Good. Now I think you got it. Okay. All right. Questions on it? All right, I'm past my time. Rylan, what do you got? No, go ahead. Oh, come on, dude. I thought I was going to get to answer a question. All right. Very good. All right, so your assignment is going to be the worksheet that I'm about to hand out. Let me get that for you. Okay, Jacob's question, we didn't address the domain and range here. Domain is all real numbers, right? Because it goes on forever. I hope we've addressed that enough in this class this year, but the graph keeps going on forever for x, but the range, this line is approaching this line right here. What y line is that?
0.
That's at 0 on the y-axis. So our range is y, it's approaching 0, and it's above that line, so that's greater than, okay? Greater than. So our range is y is greater than 0. All right. Hey, will everyone take a look at number 12 real quick? No, this is on your student journal. Take a look at 12 real quick. Hey, if you have equations today, they say write an exponential function. Remember, an exponential function, you're looking in the form of y equals ab to the x. A stands for what? That's A is our y-intercept. So make sure you define that. Maybe up here somewhere you're writing down a reminder to yourself, that's your y-intercept. B is your rate of growth or decay. So growth or decay rate. All right, so I know you wrote this in your notes yesterday, so you have it, but it might be a good thing to just remind yourself of. So if I'm looking at this, my y-intercept is when x is 0. So what's the y-intercept here? 3. So A equals 3. What's my rate of growth? Or what am I multiplying by every time?
6.
Yeah, by 6. So B is 6. So I'm multiplying by 6 to get that, times 6 to get this, and I keep multiplying by 6. So whenever I multiply by 6 and I keep multiplying by 6, that's my growth rate. So that means y equals AB to the x. Well,
So A is your growth rate?
no.
A is your, oh, A is, okay.
Y equals ABX. A is our y-intercept. B is our growth rate. Okay? So you should be able to pick that out here, right? You could either put it in table form or calculate it just by looking at this. How's y changing every time? All right? Very good. If you want to do that one, I'll put up the answer for 13 here in a minute if you want to try that one. Okay, there's number 13. Oh, hold on. Did I get that right? Times 2 times 2. Yeah.
Wait, why is it negative 0?
Oh, whoa. I messed up completely. I went backwards. Unbelievable. This would be 1/2. Because I'm going the wrong way. That's ridiculous. I went backwards. Jeez. So this would be 1/2. We should be going that way. That's my fault.
Wait, Mr. McCoy?
Yeah?
So why would it be y equals negative 0.5 times 2 to the...
This would be 1/2. I messed up there, but this is my y-intercept, right? Okay.
And then that should decay or grow this up. Okay.
Yep. Okay, sorry about that. Hey, okay, so if we look at that assignment on number 1 and 2, this one, determine if it's an exponential function. That looks like it is. That's good, but this one's a bit different. Notice my b is negative. Okay? Think about if I made a quick table. I won't spend a lot of time on this, but there's x and y. If I made x 0, that makes that 6, right?
Yep.
Because this part's gone. If I make x 1, if I raise a negative to the first power, that's negative 11 times 6, or negative 66. Everyone with me there? So think of your coordinates. That's 0, 6. That's 1, negative 66. Get a picture of that in your head.
Wait, but
No buts yet. Okay? Now we go to 2. And we put 2 in. 2, negative 11 times 2, or excuse me, squared. Negative 11 times negative 11 is what? 121 times 6. Someone do that real quick.
726.
Dude. 726. Okay? Notice now we went from 0, 6 to 1, negative 66, and now we're at 2, 726. This graph is going crazy, right? We're at 0, 6, somewhere up here, let's call it there, and then we're way down here at 1, negative 60, obviously not to scale, I'm just trying to make a point here, okay? So we're here, we're there, and now all of a sudden we're way back, like off the page. You guys can't even see the graph, okay? Or we're way back off the page once we get to 2. There's 0, we've got our 1 down here, and when we get to 2 out here, we're like, I mean, it's way up here. So this graph's going boom, boom. It's like doing some crazy zigzags. Is that exponential?
no.
No. This keeps flipping, positive, negative, positive, negative, positive, negative. Because when you raise a negative to an odd power, you get a negative. When you raise a negative to an even power, you're going negative times negative at the end, you get a positive. So it's going to keep flipping back and forth between positive and negative. Is that what you're going to say?
Yeah, I was gonna clarify.
All right. So Declan, you had a but. But what?
Oh, I figured it out.
All right. Cool, man.
I just was the brain part.
So it's not exponential.
Not exponential. The picture would not be exponential at all.